Now you've probably multiplied numbers by 10 before and perhaps also divided them. And I bet the method that you used was if you want to multiply a number by 10, say you multiply 5 by 10. We know the answer to that is 50, but the quick way of doing it is you just write the number 5 and then you just chuck a 0 on the end and you get your answer. Now, the reason that this works is because if you think about a large number, let's just write a big number down. All right, we've got 31,247 there. What this number means is 3 10,000s, 1,000, 2 hundreds, 4 tens, and 7 ones. You can break it up and name the columns. Now, every column as you move towards the left is 10 times the size. There are 10 ones in 10. There are 10 tens in 100. There are 10 hundreds in 1,000. There are 10,000s in 10,000, and so on forever that way. So if you want to make a number 10 times bigger, what you can basically do is just take it out of the column that it's in and drop it next door into the column that is 10 times bigger, and that makes it worth 10 times as much. So if you've got a number like 5 that's just sitting there in the units column and you want to turn it into a number that's 10 times bigger, you're basically bumping it next door to put it over here. And what's left is nothing, which is why what you get is 50. Now, a more sensible way to think this through so that it will work with any number, not just whole numbers, because we'd like to multiply numbers that are maybe decimals and multiply them by 10 as well. Let's say we've got a number like 2.4, which is 2 and a bit. It's a little less than 2.5, isn't it? If we want to make that 10 times bigger, this idea of throwing a 0 on the end really doesn't work, because 2.40 is exactly the same size as 2.4. It's still just a little less than 2.5. So putting a 0 on the end doesn't work once you have a decimal point and then some numbers following it. But it does stand to reason that as you move this way through all of the columns that go towards the right, the same thing happens as what's going the other way. Each column is worth 10 times less than the one before. So 10 hundredths make 1/10, and 10 tenths make 1 whole. And this pattern continues on both sides of the decimal point. So instead of using our old strategy of just chucking a 0 on the end, what we want to do is bump everything up 1 column. So if we wanted to multiply this number by 10, what we need to do is think, well, we don't want the 2 to be in the ones column. We want it to bump next door and sit in the tens column. And instead of the 4 being in the tenths column, we want to bump it up and put it in the ones column. Our decimals staying in the same place. And this 0 will bump up from being in the hundredths column to being in the tenths column. So our answer is 24.0, or in other words, exactly 24. Now, if you've got a really long number, let's say we take a number, we'll write down something similar to what we had before, but we'll put some decimals in it. Rather than that concept of taking all of the numbers and bumping them all up 1 and leaving the decimal almost like a placeholder in the same place where it was, it's actually easier to leave all the numbers where they are, and instead of moving all them up and leaving the decimal the same, just moving the decimal the other way. So if we want to make this number 10 times bigger, we can basically promote everything by just moving the decimal 1 place along. So let's write this out nice and neatly so we can see what's going on. 3,124.32 times 10 will give us, well, we just move that decimal 1 point to the side, and we get 31243.2. So instead of 3,000 and a bit, we got 31,000 and a bit, and you can clearly see that that number is now 10 times bigger. Now, once you know how to do this, you should be able to equally well divide. If multiplying means we move the decimal 1 place to the right to make the number much bigger, it stands to reason that we can divide by 10 by moving the decimal the other way to the left. So if we have a number like, let's say 671, let's give it some decimals, 671.2, and we want to make it 10 times smaller by dividing it by 10. It stands to reason that we can move the decimal point 1 place this way, and we'll get around about 67. To be exact, 67.12. And you'll notice that we have all the same digits in our question and our answer, but the decimals just moved. Now, some people like to memorise which way the decimal moves. When I multiply, I must move it to the right, and when I divide, I must move it to the left. That's fine, but when you memorise something, sometimes you forget. So it probably makes more sense just to look at it and think each time, will moving it this way make the number smaller? Yes, that'll make it only 67. That's a lot smaller than 671. And moving it this way, that'll turn it into 6,712. So that's definitely making it bigger. And if you just look at it and think about it, you won't make as many mistakes that way. Now, there's a few modules that are much the same. So if this all made sense to you, you can get 3 modules for the price of 1, because there's another module called multiplying and dividing any number by 10, 100, 1,000, ... And this really just means instead of moving one place to the left or right with our decimal, we can move more than 1. Now, if you multiply a number by 100, that's the same as multiplying it by 10 and then multiplying it by 10 again. And if you multiply by 1,000, that's the same as multiplying it by 10, multiplying it by 10 again, and then multiplying it by 10 again. You can multiply by much bigger powers of 10, of course, by doing the exact same thing. And however many zeros they have, that's how many times you're going to move your decimal place. And you can move it by multiplying or dividing. So to look at a couple of quick examples, if we take a number like 23.152 and we want to multiply it by 100, we're making it bigger, so we want to move the decimal this way to make the number much larger. We move it 2 places to the right and we get 2315.2. So it used to be 23, now it's 2,315. It's definitely got a lot bigger, 100 times bigger, and we've moved the decimal twice because there's 2 zeros in 100. If we took the same number and we wanted to make it 100 times smaller, we'd need to move the decimal 2 places to the left. And that would put it here, just before the 2. Now, if we have a number that doesn't have any whole digits in it, we often put a 0 before our decimal place. We've got 0.23152. Notice I just put all of the all of the digits down in the order that they appeared in the question in my answer, because the only thing that's moved really is the decimal point. Now, sometimes you'll get a question where you need to actually make some zeros to jump over. Let's have a look at this one. 52 is 52 exactly, so it doesn't really have a decimal in it, but notionally its decimal point is here, isn't it? At the end, it's 52 point nothing. So if we want to divide by this big number here, which is 10,000, which has 4 zeros in it, we're going to need to make 4 jumps of the decimal point to the left. So you can do your working straight on the question here. 1 jump, 2 jumps. There's nothing else to jump over, so I need to put some zeros to jump over to make my 4 jumps, and the decimal needs to finish here. So when I go to write my answer, I know that there's really a 0 at the front before I write my decimal because I don't have any whole numbers. And then I have 0052. And that's how you do it. Similarly, sometimes you'll need to put zeros to jump over the other way. So if I had 52 times 10,000, then that's just saying our decimal is here, but we're going to move it 4 places along. It might be nice to just put your 52 down with its decimal and then think about making your 4 jumps. 1, 2, 3, 4. And now you've made a bit of a mess here, and it's probably nice to write the answer nice and tidy without any jumps on it. We have 520000, so that's 520,000.